Okay, so here's number 22 from 12b. So what is the largest possible area of the triangle in the complex plane with the vertices 2z, 1 plus iz, 1 minus iz, as is a complex number, so that's why they say equation. So like the first thing I realize, all the numbers has z as product, so which kind of reminds us this scaling a number, like complex number by that z. So that might be useful. And then another thing we have in the equation, maybe we can find the z in this equation. Like if I pull the 4 out of the absolute value or just the magnitude, so you can say that's 4 times z minus like 1 over 2 is equal to 1 because I can pull that 4. When you divide by 4, so you get the z minus 1 half is equal to 1 over 4. So like most of you should be able to see what does this actual graph look like, but it's actually a circle at center at 1 over 2, which has a radius of 1/4. So if you don't see immediately, you can always, let's say z is like a plus bi, and then you can say a plus bi, a minus 1/2 to the second power plus maybe b square is equal to the square root of this guy is equal to 1/4. So that's how you find the modulus or the magnitude of the complex number. So in absolute value, so you can just square both sides. So you get a minus 1 over 2 square plus b square is equal to 1 over 4 square. What does that equation look like? This is a circle at center is like 1/2 comma 0. And the radius is like 1 over 4. Again, this is just additional work. We just don't need this. As soon as we have this one, we should know this is the actual case. So anyway, so that is the circle centered at 1/2 and a radius of 1/4. Okay, so then now what? Like we do have the 2 times z, 1 plus iz, 1 minus iz. So we are gonna basically scale in the points like 2. I'm gonna say 2 plus 0i, and then 1 plus I, 1 minus I. So we are scaling these 3 points by z. So when you scale by z, you actually multiply all the sides by the magnitude of this one. But when you multiply all the sides by this, the areas is actually going to be multiplied by the square of the magnitude of z, because that's 2D. So which means we may find the area of these points, and then we can just find the z and square them to get the largest possible. So you can plot these on the complex plane if you want to, but it is not actually needed. So 2 plus 0i will be like something right here. 1 plus I will be something right here, and then 1 minus I will be here. So you just have a nice small triangle here. That's 2 units, that's 1. So 2 times 1 times 1/2, so which is area 1. So the area of the points from these are going to give us 1, but we are looking for the after scaling by z, right? So which is gonna areas will be 1 times z squared. So the question we should ask, so what does that like give you the maximum number? So where do we get this maximum? I'll say the max of this is what we're interested. Since you know the center is 1/2 and the radius is like 1/4, so the maximum actually will be 1/2 plus 1/4. So you will get the 3 over 4. So this is the size of the maximum z. So you can just say that's 3 4, but we are going to square that. So you should get 9 over 16 to get the area of the scale version. So which is choice C. Okay, so that was like number 22. To be honest, this was not really that challenging. So for number 22, but anyway, so that was our solution.